us to find the inverse of f of x equal to x minus 7 all over x plus 10 and find f inverse of 4. So we have a rational function going on. Remember, our rational functions are just fractions on steroids. They got variables going on within the fraction. Okay, the rules are still the same. Step 1, replace f of x with y. So we're going to have y is equal to x minus 7 all over x plus 10. Step 2 says we switch x and y. So instead of y equals, we're going to have x equals y minus 7 all over y plus 10. And remember that we are solving for y. I know that you hate fractions. Almost everyone except for mathematicians and bakers hate fractions. So let's go ahead and get rid of the fraction. What we're going to do is take both sides of our equation and multiply it by our denominator, multiplying by the LCD, least common denominator, or in this case, the only denominator. So we're going to have x times y plus 10 is equal to y minus 7, because on the right-hand side, the y plus 10 and the y plus 10 take each other out. Okay, still solving for y, but we can't get y by itself right now because it's on both sides of the equation. So what we need to do is distribute our x. X times y gets us xy, plus x times 10 gets us 10x, and that's going to be equal to y minus 7. Remember that we are solving for y, which means we need to get all of our y's onto one side and everything without a y to the other side of our equation. So I'm going to take xy, and I'm going to move that 10x to the other side. So I have y minus 7 minus 10x, because my 10x was positive, so I subtracted. Still need to move that y on the right-hand side over to the left, so I have all my y's on the left. My xy is still there. Subtract y from the right-hand side to the left-hand. I have negative 7 minus 10x. Keep in mind that this is the same thing as negative 10x minus 7 on the right-hand side. Whichever way you want to look at it is fine. We do not have the y by itself yet on the left-hand side, and we can't combine xy and y because the first one has more variables than the second term. But we can say that they have a GCF, the greatest common factor of y. Both sides have a y. So let's factor it out. If I factor out a y from xy, I'm left with x, carry my minus. Factor out a y from y, I'm left with 1, equal to negative 10x minus 7. Now I can divide both sides by the x minus 1. I get negative 10x minus 7 all over x minus 1. And then my last step, remember that you need to replace y with your inverse notation. That way everybody knows that this inverse goes with that function. And we solved the first part of the problem. First part of the problem said, find the inverse. The second part says that we need to find f inverse of 4. So that means that we need to plug in a 4 every time we see an x in our inverse. So instead of negative 10x minus 7 in the numerator, we have negative 10 times 4 minus 7. And in the bottom, we have, instead of x minus 1, 4 minus 1. Up top, doing the arithmetic, we should get negative 47. And in the bottom, we get 3. So we found that f inverse of 4 is equal to negative 47 all over 3. Okay? If they ask for the ordered pair, it would be 4, comma, negative 47 over 3. Now, this problem asked us to find the inverse. If it only asked for f inverse of 4, remember f inverse of 4 is the same thing as f of x equaling 4, because the x and the y's flip-flop from the original to the inverse. Domain and range flip-flop. So if it's an x value for the inverse, it's a y value for the original, which means we could have taken our function, the original, and replaced f of x with 4. And we wouldn't have had to find the inverse. We would have taken both sides of our equation and multiply it by the x plus 10. Distribute the 4. We would get 4x plus 40. Subtract the 4x. We get negative 3x minus 7 equal to 40. Add the 7, we get negative 3x is equal to 47. And then when we divide, we would get negative 47 over 3. So for the original ordered pair, it would be negative 47 over 3, comma 4. But for the inverse ordered pair, x and y flip-flop, which is why we would have 4, comma negative 47 over 3. It's not magic, it's math, but it is pretty darn cool.